Good morning. I am Dr.R.Parameswari, Assistant Professor, Department of Mathematics, Sathyabama Institute of Science and Technology. Today we are going to see the topic change of order of integration. So we have seen this change of order of integration in double integrations. So let me start with the double integration. So double integral is integral d f of xy dA, where d is the region. Okay, and we can integrate that double integration either with respect to x first or with respect to y first. So if you are integrating with respect to x first, so that is called the inner integration. Here we are having two integrals. In these two integrals, we are going to integrate with respect to x first, and then we are going to integrate with respect to y. So if we are integrating with respect to x, we will be getting the integral of this form. We will be getting the integral of this form, that is double integration. I didn't mention the limit here because we don't know the region. So double integration f of xy, and even the function is not mentioned. In general we are explaining. Okay. So f of xy dx dy. So what is that dx? Why I have written dx? We are integrating with respect to x first. Okay. So first inner integration is with respect to x. After completing, we have to proceed for y. So while you are integrating with respect to x, we have to treat y as a constant. Suppose if anyone wants to explain, that is integrating with respect to y first. Integrating with respect to y first, then we'll get the integration is of the form double integration f of xy dy dx. Inner integration is with respect to y and outer integration is with respect to x. Okay. Now the limits, we have to check for the limits. If the limits are the constant limits, either you can get the constant limits or the variable limits. If the limits are constant limits, then no need to worry about the order, because we will be getting the same solution even if we are integrating with respect to x or with respect to y, the inner integration. Suppose if it is a variable limit, then only we must concentrate on the order. Okay. Suppose if the limit here I have mentioned f of xy dy, right? If it is a variable limit, it must be the limit for y. So limit for y means we should have the limit in terms of x. We should have the limit in terms of x. Okay. And if the inner integration is with respect to y, we will be having the limit here, the limit as in terms of x, and the outer limit is the constant limit. Okay, the outer limit is the constant limit, and that can be integrating with respect to x. Once if you have integrated with respect to y and you are having the variable limit, means we will be getting the solution in terms of x alone. That is, the two variable function becomes single variable. It should be in terms of x. See, I am talking about the inner integration with respect to y. So the vice versa you have to understood. If it is with respect to x, means we should have the limit in terms of y. Yes. And we often say that the first integration is in dx dy order and the second integration is in dy dx order. In some situations with the same order we can't integrate, because depending on the limit, okay, we can't integrate with the same order. So at that time we are using this changing the order of integration and getting the solution easily. Okay, we are switching between dx dy over dy dx. That is called the changing the order of integration. Okay, now we will see for changing the order of integration what we have to do, how we can do the integration easier. Okay, the following are very important when we are using the change of order of integration. We have to check the limits of inner integrals. If the inner integral limits are function of x, then the first integration should be with respect to y. That is, if the limits are in terms of x, we should integrate with respect to y. The order must be dy dx. And first of all, we have to identify whether the given question order is correct. How we can check? We have to check the limits. Outer limit is a constant limit, inner limit is the variable limit. and we have to check whether the variable limit is in terms of x, function of x, then the order must be dy dx. Suppose if the inner integration limit are in terms of y, that is function of y, then the order must be dx dy. Okay. Then what we have to do? After checking the order, if the order is correct, then we can write the boundaries. Write the given limits. We know inner integration is for y means dy dx will get. So, the inner integration limit is for y is equal to. Inner integration you can write the limits as y is equal to, and y is equal to the lower limit and y is equal to the upper limit is the boundary, and the outer integral limits are boundaries depending on x. So, we will be writing x is equal to the constant and x is equal to the upper limit constant. Okay. So, after identifying the boundaries, the easy way to integrate, that is to change the order, is we have to draw the region by using the given limits. Then, after drawing the region, if the given order is dy dx, then we are going to change the order. How we are going to change the order? It should be dx dy. Okay. So, if the inner integration is first with respect to x, keeping y as a constant, we have to keep y as a constant and integrate it. And then for that we have to consider the horizontal strip in the region. First we have to draw the boundaries, identify the region. If the integral order is dx dy, inner integration is with respect to x, draw the horizontal strip. Okay, draw the horizontal strip and find the new limits accordingly. We have to find the limits for that change of order. We have to find the limits for x now. So, what will you get? We will be getting the limit for x as a function of y. As a function of y we will be getting. And the same point is repeated for y. If the integration is first with respect to y, keep x as a constant, then what we have to do? We have to draw the vertical strip. We should draw the vertical strip and find the new limits for y. So, we have find out for the inner integration, then what is how we can find for the outer integration? If it is the horizontal strip, that is if we are finding with respect to x first, then we will be drawing the horizontal strip and then we have to move the strip over the region. How we can move the horizontal strip? Horizontal strip will cover the region only by going down and upward direction. So, if the strip is moving down to the boundary, down in the region, it will meet the boundary. That will be the limit for y, lower limit for y. And then you have to move the strip towards upward direction. You have to move towards upward direction and it will meet the boundary, the another boundary, that is a limit for y, that is the upper limit. The same way we have to proceed for x if the inner integration is with respect to y. How we can proceed? It is a vertical strip. If the inner integration is with respect to y, it is the vertical strip. So, what we have to do? We can move the strip towards left and right direction. Okay, we can move the strip towards left and right direction. So, towards left will meet the boundary. That will give you the limit for x, that is the lower limit. And if you are moving towards right direction, that will meet the another boundary, that gives you the upper limit of x. Then we can use the integration and proceed. While you are integrating with respect to y, we have to treat x as a constant. And then we will substitute the limit for y, then the function will be reduced to function of x alone. And then we can integrate with respect to x, substituting the limits of x, we will be getting that integral value easily. The easiest way is you have to draw the region first. With algorithms or anything, we can't do this easily. Only with the diagram, we can proceed easily and we can identify the region easily and finding the boundaries for the new integration, that is after changing the order. Okay. Now we will proceed to the problem. This is very important problem. Change the order of integration and evaluate. The question is integral 0 to 1, integral x to 1, e power y square dx dy. For changing the order or for anything, just first of all we have to check the given order. Even for evaluation also, if it is a variable limit, we have to check the order of integration, whether the given order is correct. the inner integral limits are function of x. If it is a function of x, the inner integration must be with respect to y. But what about here? Here it is given as dx dy. So, the given order is not correct. So, first of all, we have to rewrite the question. We have to rewrite the question and then only we can proceed. So, if you are rewriting the question, we will be getting integral 0 to 1, integral x to 1, e power y squared dx dy. That is the correct question. Okay. Then you can check whether we can easily find out the solution. You have to check the given function. See, the given function is having e power y squared. We don't have any formula for e power y squared. E power y squared integral formula does not exist there. Okay. So, we are going to change the order. If it is e power y, we can integrate easily with the given question itself. But for e power y squared, there is no integral formula. So, what we are going to do is, we are going to change the order. So, before changing the order, first we will write the boundaries of the given question. So, the first integration, the inner integration is with respect to y. So, that is a limit for y. So, we are writing the limits as y is lying between x and 1. And the outer integration is for y. So, we are writing the limit of x as 0 and 1. Okay. So, we are going to draw the picture by using the given boundaries. What are the boundaries? We are having x is equal to 0, x is equal to 1 and y is equal to x, y is equal to 1. Okay. So, we have drawn the boundaries here. And after drawing the given lines, you can easily draw this. If this is a straight line given, so you can easily identify the line given straight line equation, and we have drawn through origin. It is passing through the origin. Any curve you can draw easily. What we have to do? We have to plot the points. Plotting the points and joining those points will get a curve. Even if it is a parabola, no need to worry. Y squared is equal to 4ax or x squared is equal to 4ay, whatever it is. We are going to plot the points. We will have x column and y column. Substitute x is equal to 0. Then what about the given curve? Y squared is equal to what we will get. Okay. Similarly, we can find for the other curves also. Plot the points in the graph and then joining those points will get a curve easily. Okay. No need to remember all the standard curves also. You can plot and join the points and get the curve. So, here this is a region. Now, we are going to change the order. This is a correct question. That is, y is equal to x is a boundary here and y is equal to 1 is a boundary there. X is equal to 0. X is equal to 0 is nothing but the y axis. So, we are having y axis as the third boundary and x is equal to 1. X is equal to 1 is the line here. So, it will meet at that point. So, we are avoiding that. Only that point is needed. So, the region is this one. This is D. This is the region. Now, what we are going to do? We are going to change the order. So, if you are changing the order, what we have to do? This dy dx becomes dx dy. So, if it is dx dy, draw the strip parallel to x-axis. So, if you are drawing the strip parallel to x-axis, it will meet the boundary x is equal to 0 and the boundary, that is the line y is equal to x here. So, we have to write the limit for x now. So, x in terms of y. So, here in lower limit, inner integral limits are x is equal to 0, x is equal to y. Okay? And we have to find the limit for the outer integration. How we can find the outer integral limit? We have to move the strip towards downward direction because it is the horizontal strip. It is the horizontal strip. So, move the strip towards downward direction and towards upward direction. So, moving the strip towards downward direction, where it will meet? It will meet at this point. So, what is that point? That point is 0. Okay, y is equal to 0. At that point, y is equal to 0. And moving towards upward direction, it will meet the boundary y is equal to 1. So, the limit is 0 to 1. See, now we can integrate this easily. We are going to integrate with respect to x. We are having the function is e power y squared. So, with respect to x, y is a constant now. So, that e power y squared itself is a constant. We are going to substitute only, we are going to integrate integral dx. That's all. Okay. So, integral dx is x. So, we are having the inner integral x into e power y squared, and the limit is for x and it is in terms of y. So, x is equal to 0, x is equal to y, and this is for outer integration dy. Okay. And substituting the limits, what will you get? Upper limit minus lower limit. Upper limit is y, lower limit is 0, and e power y squared is constant with respect to x. Okay. So, we are having now the integral function only in terms of y. So, y into e power y squared dy, and that is between the limit 0 to 1. So, how we can integrate that? Y into e power y squared, by the substitution we can integrate easily. So, using the substitution, y squared is equal to u, y squared is equal to u. So, once if you are changing into other variable, you have to check the limit, also we have to check the derivative also, integral derivation also. Okay. So, dy becomes 2y dy is equal to du. We are having y dy. So, that is replaced as du by 2. Du by 2. See, now we are having only e power u. E power u integral value is easy. Integral formula is e power u itself. E power x integral formula is e power x itself. So, using that 1 by 2 into e power u, that is between the limit 0 to 1, e power 1 minus e power 0. And you know e power 0 value is 1. And I hope you know the value of e power minus infinity as 0 and e power infinity as infinity. Okay. So, we have arrived at the solution of this given integral easily by changing the order of integration. Thank you. We'll meet in the part 2 of the same title.